Welcome everyone. My name is Heike Ritter and I will be your host for this webinar. Thanks for joining and thanks for being part of our community. A few reminders before we start. So this webinar will be about an hour. It will be recorded and shared publicly afterwards on our community at aka.ms/security webinars. I, by the way, posted all those links that I'm going to announce now in our Q&A announcement chat window. So during the webinar, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on Ask a Question. Questions you post will be made publicly visible, and if you prefer, you can also post your question anonymously by checking the box right below where you enter it. As you can imagine, we often get many questions during these webinars, and really we are doing our best to respond to all of them in real time. If the answer was not provided or if you have additional questions afterwards, so please don't hesitate to ask them on the Microsoft 365 Defender forum at aka.ms/m365dtc. If you're listening to this after the fact as a recording, you can also use that place to ask questions. We love to hear your feedback on how we can improve these webinars, so please afterwards do that at aka.ms/security webinar feedback. This is really important to us so we can deliver the content that you need. And then lastly, if you haven't already, please join our security community at aka.ms/security community, as well as our Microsoft 365 Defender community at aka.ms/m365dtc. And that's always the best to ensure that you don't miss any announcements, future webinars, and such. So today I'm super excited to have Michael Malone and Tali Ash back with the series, and Sebastian Molledink as a guest speaker in our Lead Speak Hunting series, who will share how you can leverage advanced hunting for multi-stage incident investigation with Microsoft Cloud App Security data. So I think handing over to you, Michael.
Awesome. Thank you, Heike. Yep, so we're excited to bring you some really good content today. Before we start to dive into the MCAS content, the Cloud App Security content, Tali and I want to cover some of the topics that we're going to be using, or Sebastian's going to be using, performing the hunt. One of them is going to be working with dynamics. Now, in tracking the adversary, we did talk a little bit about dynamics, but wanted to cover a couple things in case they're new to some of our attendees. So, a dynamic is an object-oriented format for storing structured data. Essentially, you're typically going to be looking at JSON strings that have been ingested and converted to something where you can actually go through the individual items inside the list. So the two different operators you're most commonly going to use for this is going to be toDynamic or parse JSON. They essentially do the exact same thing. In fact, even in the documentation, they're essentially two names for the same function. It's also worth noting you can use parse XML as well if you would like. So if you have an XML content, let's say you grab some data using external data that you want to be able to turn into XML, parse XML will do the exact same thing, turn to dynamic for you. So to start out, we're going to take a look. We're going to use a very simple little query here. We're going to say let JSON string is equal to, and I just made this little hello world string here essentially, where hello is equal to leet and world is equal to a list of wibble, wobble, and wobble. And as you can see, when I print this out, remember print is because we're using a scalar. toDynamic is a scalar, just like an integer or a string or a double. We're going to turn into dynamic. It looks just like a regular string at this point. The big difference here is you'll notice that it's actually broken out in the side here as different objects. So we can see that hello is now a named item that's set to delete, and world is now a list of wibble, wobble, and wobble. So it shows you a little bit of what's behind the scenes on how this all works. Now, one of the big benefits you can use when using a dynamic is you have a couple different ways to index the array, the members of that object. So the first way is dotted notation. So like column.child. The second way is by naming using square brackets. So column bracket quote child quote. So using our previous example again, I'm going to take the same string, print it out to dynamic JSON string, and then I'm going to use the extend operator to add a couple of columns here. I'm going to call hello by a dotted notation and world using the square bracket notation. So what we should see here in just a moment is our same hello world string with a new column called hello and a new column called world that reflects the contents inside the JSON object. You can see hello is now promoted to a specific column, just as is world. Now, when you're interacting with lists and arrays, so this is another one here. So world here is world here is a list or array or a set, depending on how you want to describe it. There's what you can do is you can actually iterate through this using an operator to identify which item in the series you want to touch. So in this case, so you got to remember this is proper notation. So 0 would be the first item, 1 would be the second item. So using the same code as before, we're going to add another column here called first element, and we're going to grab world value 0, the first one, and the second element is going to be set to world value 1. So here, Wibble and Wobble, you'll see, is now promoted to a column. Now, so let's go ahead and apply this real quick. We're going to take a look at the Cloud App Events table. We're going to go look for the action type added to groups. This is going to happen whenever an entity is added to a group in Azure Active Directory. We're going to take a few of these, and we're going to take a look at one of the columns that we would want to work with this in. So, like for example, raw event data. You'll see we've got an account object ID here, which you can click on, and it'll link you over to the actual user account entity in Defender, the account's display name. But then you've got this giant JSON blob. So this is really handy for when you have multiple different types of data and you're trying to put it in a single table. If we made a table for every single type of data out there, you would be struggling trying to go through all the different tables. So what we can do is we can put the stuff that's specific to a given event inside a JSON object like this, and you can turn it to dynamic and then access the items inside of it. So let's go ahead and jump in here, and we'll go ahead and use the same thing, and we'll figure out who added who to a group. In this case, we're going to have the timestamp, the applications of SharePoint Online, the IP address that performed the action, the actor again. But you'll notice here we've extracted out the target user or group name, which is letting you know which principal was added into that specific group. So really handy way to get into JSON data. And as you can see, it's the same thing here if I run this again, but using the square, actually, I think it's identifying it's the exact same query. We're seeing that, okay, there it goes. The square bracket notation brings back the exact same results. So another way to interact with JSON, and this is going to be one you'll probably use quite often, is pack array. So, and again, I want to make a quick note. So all of these the query files are available on our GitHub. So please, if you want to go try these out in your own portal, all these samples should work inside your portal as long as you have MCAS for some of the MCAS examples. All the dynamic examples should work anywhere. So pack array is going to build an array. This is the official reference to the pack array definition. So this is handy if you want to, for example, do an in operator and compare a set of, like, maybe you have a table that's got a bunch of strings in it, and you want to say, I only want things that have these 10 values. Instead of using a bunch of OR clauses, you can use a function like pack array, and it will turn it into an array that you can then use with the simple where clause using the in operator. Now, it's important to note that a dynamic is not a string. Even though it looks like a string, if you try to perform operations such as, like if you wanted to do summarize by, or if you're doing an equals and comparing it to a string, it's not going to work unless you tell it it's a string. So once again, to do that, we're going to use the toString operator. You can see once again we're comparing hello to hello. In this case, toString comes back normal. In fact, we can comment this guy out here just to show you. On this here, there we go, and it'll come back as a string. We can also turn that to an integer if we want, because it's 1337. Now, bag unpack. This is great if you've got a pretty complex dynamic object, and you want to get at that first layer of items, if you will, inside the object. So bag unpack is going to automatically unpack that entire first level. So in this case, is going to figure it out that we have a column called hello and a column called world. So this will automatically put as many columns as you have in the first layer of all these of objects inside the JSON. It'll break it out into individual columns. And there's also an option here to always write code live, right? That's what they say. Yep, there we go. So there's a really handy feature of this operator. So if you have something that might conflict, so for example, let's say the JSON object has a field called SHA-256, and the table has a column called SHA-256. If you try to run evaluate bag unpack, it's gonna kind of crash on you. It's gonna throw back an error. So what you can do is, if you know that there's something in there that's gonna have a conflicting namespace with one of the columns already in the table, the second operator, if you want to put it in there, will let you add a prefix to all the columns. So you'll know now these are called test hello and test world, so that if you ran that in that SHA-256 example, it's not gonna crash and give you problems. Another very common one we run into is MV-expand. This one's a little bit harder to get into. So MV-expand is gonna multiply elements in an array across a tabular data set. So let's go ahead and take a look here. So we've got our same example before, hello world. But this time we're going to do MV-expand world. So first we're going to do a evaluate bag unpack. This will give us the same example we have below, and MV-expand world. Now what you'll see is we're going to have 1337 3 times. So by running this, we're going to have it 3 times, 1 for wibble, 1 for wobble, 1 for wobble. So in this case, this is really handy if you have if you want to do some filtering where maybe there's an array condition associated with your dynamic object, and you only want to get it where it's a specific value. In fact, in episode 3 of Tracking the Adversary, we used this to filter out where we had spikes in our anomaly detection, because all the data sets were it was basically 2 different lists next to each other, and we were looking for a spike where we saw a flag set to 1. So the only way for us to efficiently get in there is to MV-expand it and multiply it out to find the ones that have a 1 there. So this is really handy for figuring out the items inside the array if you want to access them individually. So let's go ahead and put this into practice here. So now this is kind of an interesting example here, because you can see we're actually comparing a dynamic to a dynamic. So this is basically saying, I want the objects here to be exactly equal to groups for the activity objects type. So we're going to look for where we had added to group, where we had a group essentially was added, and using the exact same notations we did before. So timestamp, application, IP address, actor. We can see the events, who did it, what the principal was, and the group that they were added into. And so Tali's going to talk a little bit about a date time function that we're going to be using a little bit later on. That should be using a little bit later on in the MCAS hunt. Tali?
Thank you, Michael. So before I'm talking about the start of day function specifically, I wanted to mention something that we were asked a lot recently, and it's how we display the time of the activities, which you can see here timestamp in advanced hunting. So first of all, the results, as you can see here, are based on the definition of the time zone that you configured in the settings. So if the settings are configured to show the time in the portal for you to see, you can see here the time also in UTC in the results. If the settings are configured for local time, the time in advanced hunting will be local as well. But it is super important to know and remember that all the time filters that you write in the editor inside the Cousteau query are based on UTC. So our recommendation is to work in UTC time. It's also very valuable if your SOC is spread across the world, different time zone. So just remember the results are based on the settings. However, the query itself is, and the filtering in the query is always UTC time. And start of day function is very efficient, as we will see here. When we will hunt for a specific incident that happened at a specific point in time, we would like to search for activities that happened around this time. So start of the day will give us the beginning of the day that we are mentioning. So here, for example, it was the first day of the year. We wrote that it was 10 in the morning, but we can see here that the start of the day, oh, this is interesting actually, because what we see here in the result is local time and not UTC. If it was UTC, we are getting the start of the day. So yes, this is a bit about start of the day function. You can find in the documentation many other useful functions for time filtering. And with that, I will hand it to Seb that will walk us through a hunting scenario on top of MCAS alerts.
Great, thank you, Teddy. So let me share my screen and let's confirm that you can see it before I start to talk.
We can see.
Okay,
Yes.
perfect. So hi everyone, I'm going to start with the M365 security portal and a multi-stage incident. So here is something that you've probably seen in your environment, and this is an incident that has been created in Microsoft Defender with different alerts that we saw here from Cloud App Security. So we can see that I have a few impossible travel alert, activity from Tor IP, but you could have also many different type of other detection that would be aggregated. So how can we use advanced hunting with such type of incident? So the first thing that I want to show you here is the context of this incident. Of course, if you look at the incident page, you will have a timeline, and you can see that the first alert that we had here started the 4th of May around 10 a.m. on my time zone, and it ended a few minutes later. So probably that's something that I'm going to reuse during my queries. So that's why it's important to identify also the time frame that I want to target in my queries. And another thing that I want to show you also is the impacted user. And this impacted user is, in my case, named Megan Bowens. She's a marketing manager, and we can easily see here that she has an investigation priority of 268. So that's a user which is considered as risk by Microsoft Defender. And something that you maybe have seen is that we have now also the user profile that's exposed to let us know the details about every user, the different risky activities that we saw for that user. And something that I'm going to use also to continue to talk about the context of this investigation and this user is that we can see here, in addition to the fact that this user is considered as a high risk by Azure AD, is that we expose under location the different location that this user has been using in the last 30 days. So if I click on the location here, we can clearly see that this user is mainly accessing our platform using the United States IP addresses, Belgian ones. So this is me, so you know that I'm Belgian now, and also Israel. And if we continue to look at the other activities, we can see also that we had a few other activities that occurred from different locations like Singapore, Germany, Ireland, Albania, and United Kingdom. But if you look at the last activity that has been seen, we can see that just like for our incidents, we have activities that occur on the 4th of May. So I'm going to use those specific locations, Singapore, Germany, Ireland, and Albania, to look in my data and find specific evidences of what really happened on that user. So you may be wondering why I'm going to use advanced hunting to look at those activities, because they're coming from Microsoft Cloud App Security. And if you know Cloud App Security, you know that Cloud App Security proposes an activity log, which is a graphical interface that allows you to search for a specific activity. So this is a very user-friendly environment. But the downside of this environment, if I perform a simple query like this one, so I'm looking for activities that will be from other location, for example, for my user, you can see that I have easily a few hundred of activities for that specific user. And if, as an analyst, I go through those activities I'm trying to scroll down those pages, and again, a few hundred activities is a lot, I can easily miss specific activities within all the things that we display here in this environment. And that's why I'm going to use advanced hunting. The second reason I'm going to use advanced hunting is because if we look at those activities, I see that I had some activities that occurred from different locations, like Albania, that was considered as unusual for that user. If I open this activity in Cloud App Security, I don't have much information that I can query. But if I open the raw data that we have here. So this is something that Michael showed you that I'm going to use extensively within the advanced hunting part. You can see that a user accessed here a specific email. So I have details about the emails here. So I have my internet message ID, but I cannot do real investigation, like for example, searching for the specific folder where this message is used, or extracting the message IDs from the activity log that we have here. All this information is hidden and cannot be queried because it's not indexed, unfortunately. And this is where advanced hunting becomes very handy to perform the investigation. So now let's move to advanced hunting. So I'm going to use the Cloud App events table, so the data coming from Cloud App Security. And something that I want to tell you is that this table, so if I expand here, do not contain the account UPN for my user. So if you look at the structure of this table, and let's scroll a little bit, you can see that we have different properties like the action type, the application ID, the account object ID or account display name, but we don't have any information like the account user principal name, which is something that many analysts are actually using very often to perform specific queries within their data. So the first thing that we have to do to start in our investigation is to extract the account object ID, because this is the only way for us to query the Cloud App events data. So you can do this very easily by querying the identity info table, which is a table that contains all the details about our user account. And here, because this table knows the account UPN property, by running this query for my user, you can see that I will get for my user the account object ID that I'm going to be using further in my investigation. And this is something that you can already see in the further queries. So the first thing that I want to do now by looking at the different signing logs of that user is to get an overview of what happened for that user, because this is something that I've seen very often for customers that are performing an investigation. They go to the Azure AD portal and they start scrolling for all the signing events that occur for that user around the time of the events. So the first thing that I'm doing is that I'm creating a variable here where I'm using the start of the day that Tali explained for the day of the investigation. I'm then calling the Azure AD signing events beta logs, and I'm filtering for my user account object ID and the time that I extracted from my start of the day. And you can see that I'm just getting some of the properties. I don't want to show you everything, but let's run this query to have a look. So now that I have some details about the signing events here, let's look at the data. And you can see here all the different applications that have been accessing my environment, like an application like Zapier or my authentication broker, Bing also. And you have details about all the locations that were used by this user, the city, and the IP addresses of our user. We can also see on this page additional details like the device name and the trust type, if this is a device that's federated with Azure AD, and the operating system platform. So if I go down, I know that I have here, for example, a computer that has been used by a user, and this device is Azure AD joined. So this signing, for example, is something that I can use to identify the signing that has been performed by a trusted device by my user. And you can also see here that this device is managed but not compliant because it might be managed by Intune. And you have also details about the authentication requirement. So this is an easy way to look at the signing activities for the user and understand if the user went through the multi-factor authentication. We can also see the client application that's being used by the user, and we have also the user agent, which is something very useful when you're performing an investigation to understand if this is something usual for the user or if this is something that's completely exotic. So if I scroll very quickly here, you can see that I have a browser, so I have an Edge browser, but you can find probably different things like here, something that's used by a mobile device, and if you go further, you will find different type of other devices. So that's again an easy way for you to identify the potential unusual signings. And you might be spending some time scrolling here for something interesting and not necessarily finding it. And this is where you can use distinct or summarize, for example, to extract the relevant information. From here, I can easily see also that my user connected from Albania, and this is probably the signing events that I would be looking up for if I were only looking at the signing events. But in this series, what we're going to do is spend more time actually using the information that we see here to look for the actual activities that perform the malicious actor. So the first thing that I'm doing now is to understand the perform action. So again, to understand the context of my incident, I want to understand the action that the malicious actor performed. So to do this, I'm using the account ID that we extracted before. I'm creating an array of the location that we identify as suspicious for my user. So remember, when we went to the user profile, we saw that those activities that occur on the 4th of May from those locations that are not necessarily used by our user on a regular basis. And I'm using the POC array function that Michael explained before. I'm then defining again the start of the day of my 4th of May because I know that this is when my event happened. And I'm going to now call my Cloud App events with those properties. So the first thing that I'm using now is filtering those events for my user, those location, and the time to search. And I summarize by the action type to understand the action that have been performed, the country count, and I expose my account object ID to be sure that I see the details about this user. So if I look now at the action that have been bring back by my advanced counting query, we can see that those strange activities from those locations have been actually accessing files, downloading files, previewing files, deleting some emails, and accessing some emails. And here, look at this. So this is something very interesting. I have also a new inbox rule activity that occurred. So that might be something that the malicious actor used to forward interesting email outside of the company. So we're going to investigate those different type of activities that we see here to understand the scope of the breach. So let's move to the next step and review the accessed emails. So here, again, I'm reusing my different variables. And this time, I'm going to filter my Cloud App events by the action type, which is mail accessed, mail item accessed. So this is the action that we saw before. And what I'm going to do here is to expand the raw data folders. So why am I doing this? So let me first start running the first part of the query to show you why I'm doing this. So when you look in the Cloud Application event for those specific activities, this is what you get. So if I click on one of those events, for example, you will have all the details that we see here. You will have also the raw data that will be exposed. And as you can see, this raw data is of type dynamic, and it's providing a lot of very interesting information, like the client info string, so the user agent, the seed of my user, and also here, if I look at this specific piece of information, I have my folders array. So this information here is an array of all the messages that or folders that have been accessed during that specific time frame that generated this event. As you can see, we have many message IDs. So if I want to extract this information, I'll have to do some specific manipulation. And the operation that I'm going to use here in this case is the mvexpand. So let's go back now to the mvexpand and let's run this part of the command to really understand what's happening. So this time, if we look at the number of lines, we have now more lines. And if I look at one of my events and I go to scroll down to the bottom, you can see that I have a new column that has been generated. This new column now is raw event data underscore folders, and you can see that it contains an object that represents my folder or my message later on. So you can see here that we have details about the path. So this is something that's contained within the inbox. And we have also the different items within this folder that have been accessed. So this is a valuable information that I want to extract also from that specific location. To do so, what I'm doing is that I'm extending my my object. I'm adding a new column that will be path. So I'm renaming this folder.path property that I'm extracting, and I'm also extracting a new property, which is the session ID. And I'm going to explain you what this thing is about. So if, let's run actually this one with all the information. So if we look at what we have now, we have again different lines. You can see that you have more lines now. We had 21, now we have 47 because we extracted also all the messages that were in those folders. And if you want to very quickly scroll here in the data that we obtain, so you see that we have a lot of data. And what I want to show you here are the details about the folder. So what we did with this command was to extract the path. So we can see here that there were messages in the inbox folder, deleted item, oh, interesting, the finance folder, and a Project Falcon folder. So we have extracted this information. Now what we also wanted to do was to extract the items information, so the emails. So let's continue with this specific information. Now that we have extracted those message ID before, I'm going to this time project the different details that we saw before. And in this projection, what I'm doing is that I'm extracting the message ID by looking at the raw data information, and I'm looking for the internet message ID property. So this information here, and let me show you the result before joining this with another table, is going to provide me the details about the message ID that I want to look at. And if I go there now, you can see that you have all the details about the path and the message ID that have been accessed by the malicious actor. So now I can see that this message ID from the finance folder has been accessed. I don't have the details about this message, so I don't know if this is something important. I don't have the subject, the recipient, but I know that I have here some additional information. So what can I do now to go further in my investigation? I can look at a potential other data source, which is the email events table. So let's go here to the left. So what I'm going to do now is to join this this new table with the emails event table, and I'm going to do the join on my internet message ID. So basically what I'm doing here, I'm using some additional information that's contained in email events, things like the recipient, like the status of the message, the sender, the subject. All this information can be potentially saved there. So I'm going to try to extract this information by joining those two tables. So let's run the query. And here, if I go now to the right, to look at the subject recipient information, attachment, and URL count, unfortunately, you can see that I don't have this information. So why is it blank? Because if I scroll down my 47 line, you can see that I don't have anything there. The reason it's blank, so it's because we have 30 days of data. So it means that for all those emails that have been accessed by the malicious actor, those emails have been received or sent in a longer period than the last 30 days. So we don't have, unfortunately, in Advanced Hunting, the information to get the details about this email. So how can you do that? If you have to confirm to your management that maybe a very important information has been leaked, you have to get this information, and it's not there currently. Actually, we have a bonus. What you can always do is maybe use some script, or if you're good at programming, you can program that also and reuse the information that you got from Advanced Hunting, and you can call Microsoft Graph. And calling Microsoft Graph here will allow you to provide the message ID information to get all those details. So as a bonus, I want to quickly show you this. So I'm going to use Postman for that, and first get a Graph Access Token. And actually, let's first use the value that I want to get here. And I'm going to call my graph using the message ID that I got from Advanced Hunting. And as you can see here, Microsoft Graph, when I know this specific message ID using Advanced Hunting, it allows me to see that an email might have some attachment. So it has attachment. The subject here was action needed, risky activity detected for your account. So it means that my user actually received a notification that something strange happened with that account, but the malicious actor has been accessing and maybe deleting that email. And you can even, if you have the right permission, extract some details like the body preview and also the details from the user that this action happened. So just as a bonus, if you want to go to the extra mile when you're performing this investigation using the data that you extracted from Advanced Hunting. So let's move to the next step. Because we saw that the user has been accessing also some files and folders, this time I'm going to query my data to extract the folder items or file items information. So same principle, I'm reusing my actual variables, and this time I'm going to use my filter to look for other actions. So here I'm going to look for file previewed, file downloaded actions, because we saw that this is what our user actually did. And I'm going to, before show you a new way to query this data, run my query. So if we look at the data that we obtain here, we can see the different location that has been used. We see the user agent. So again, something very useful. So I might be looking for some activities from the browser, like those ones. And if I scroll down, you can see that we have, again, a lot of data within activity object of raw data. So if I open an activity here and scroll, you can see that we have some type of information that's available. So here in this example, I want to show you how to use activity object. So activity object is different from the raw data that we used before. So the activity object is actually an array that's generated by Cloud App Security when they're parsing the data. And what MCAS is doing is that it's extracting for you what they believe that's important. So things like IP addresses, like files, like application, IP addresses. All that information is extracted, so you don't have to go very deep in the raw data JSON to be able to use that information. So you can say that this is a simplified way to extract some information that's very common across the activities that MCAS sees. It do not contain all the information that you have in the raw data, but it shows you some of the entities that might be useful for your investigation. So in some cases, like the one I'm going to demonstrate here, it might be easier to use to get the information you're looking for. So what I'm going to do now is to reuse the MV-Expand that we saw before for my activity object. And what I'm going to do is that I'm going to filter my activity objects that have a type of file and folders. So I want to get only the activity object that are files and folders. I don't want to see the application. I don't want to see the IP address. What I want to see are files and folders. And I want to see also the one that have a role, which is target object. So it means that we're talking about here the files and folders that have been accessed. I'm not going to look for things like the SharePoint site, for example. So when I run this query, you can see that now I have less activities. And if I look in my activity object, I have now a line for all my activity objects. And we can see that we have here some details about the files. We have also the files ID. We have also the folder, but that's not something that's very useful for you. If we look at one of those activities, in the graphical interface, we can see that actually we have something that's humanly readable, which is a name, for example. So that's something that I want to get. So I want to get that information in my Advanced Hunting data. I don't want to get my activity objects as a table like this. So to do this, what I'm going to do this time, I'm going to use bag unpack on my activity object property. So what bag unpack is going to do, if we compare it to MV-Expand, so MV-Expand is creating new rows by multiplying the property and the table. So here in this case, bag unpack is going to extract what I have here in my activity object property, and it's going to create a new column based on the object that we have here in this specific location. So if I run this query now, and I scroll to the right, we can see that this time activity object is not containing objects. What I have here are details like the file ID and the file name. So it's much easier for me to read. If I look at the information that has been accessed by the attacker, we can see things like a letter of resignation, for example. Oops, sorry for this. We can see that we have building plans that were also stored in another user OneDrive folder. We can see also details like a credit card bank from a SharePoint site, SOC team. So this is probably something very sensitive. So here, by using this information, we can easily report the file that might have been linked from our organization. So as you can see, that this is a very easy way to use the information that you have in our advanced hunting data. So now that we know the emails that have been accessed, we know the files that have been accessed. Let's look at the deleted emails, because we saw that the attacker deleted some emails. So maybe he was trying to hide his trace. So let's look at how we can do this. And here in this case, we're going to reuse again the same variable that we had before, but we're going to use the actions move to deleted item, soft delete, and hard delete. And if you look at the way I'm calling those actions, I wanted to show that you can either use or action type equals this or action type equals that, or what you can do, as Michael explained, you can use a in and specify all the activities that you're looking for. And I'm going to also expand my activity object that we talked about before. And this time, what I want to see are the emails or the folder that might have been deleted by the malicious attacker. So I want to see if that person deleted very important email from my user or specific other additional information. Then what I do is that I'm going to also unpack my activity object exactly the same way to process the information as I did before to identify the file that have been accessed. And I'm going to look only at specific information that might be interesting for me, like the timestamp, the name of the file or folder, the ID, and the details about the geolocation where those activity occurred. And as you can see here, we only have one result, so that's pretty interesting. We can see that that person didn't hide specifically their trace. We have one activity from Ireland, and the name of the email that has been deleted is Outlook Rule Organizer. So probably something that's not very important. So we're safe. We know that we don't have to recover mailbox as items to identify something very important that might have been deleted during the attack. So let's move now to the next information. And this time we're going to look to the created rule. So in my created inbox rule, I'm going to reuse again the same information that we had before. And this time I'm going to look for an action time that contains inbox rule. So this time I'm not specifying all the events by their name. I'm not using equals. And the reason is that Exchange Online is actually generating different type of events when you're creating an inbox rules. You can create an inbox rules by using your webmail, for example. You can create an inbox rules as an administrator using PowerShell, or you could use a transport rules. So there are different types of events that could be generated. So to be sure that I capture everything that might be user-based or admin-based, I'm using the contains inbox rules. So the next thing that I'm doing there, after getting the events that are generating new rules, I'm going to extend my property using a rule parameters by looking at rule data parameters. So if we look at this information before showing you the expand, you can see that we have luckily only one inbox rule activity. And if I look at this specific activity here and I scroll down the raw event data, we can see that this rule has different parameters. So if we look at those parameters in this way, you can see that we have information like like a forward to. So this is an action that's done, and the attacker is apparently also looking for specific keyword, but that's not a very user-friendly way to read that specific information. So what I'm going to do now is to extend rows by calling the row event data.parameters, and I'm going to project only the information that I'm looking for. So again, here, if I look at this information, so we have everything that has been extracted to a specific level, and you could go further by creating maybe different columns or searching for specific parameters, or just use now this new row that we created to look at the rule parameter details. So we can see here that these rules that had been created is named dot. So that's probably not something that a regular user is going to do, generating a new rule named dot. It's forwarding the emails to a Gmail account, and it's looking for emails that have in their subject or body things like credit card, secret, password, bank, payment. So probably something suspicious. So the next thing that you could do once you have identified such rule is to either discuss with the user and delete that specific rule, or you could just disable or delete this rule using administrative tools like PowerShell or using Microsoft Graph. So those are different ways to resolve the situation after identifying such malicious inbox rules. So now that we have identified those different things that have been performed in our environment, then step 6 is going to let us identify potential other victims. So in this case, I'm just for the sake of the demo, I'm using the countries. But of course, if you're an international companies, you might have people that are working in those different countries for a legitimate reason. So what you might be doing instead of using those countries, or maybe after identifying potential malicious IP addresses, putting them in this array. And then I'm going to call Cloud App Events using the location that we defined before to identify IP addresses and accounts that have been using those specific locations. What I'm doing after this is that I'm going to join that specific information with the Cloud App Event table to look at the actual activities that have been performed. So let's start by running the first part of this query. And here we can see that we have, if I look at those information, I can already see that we have different accounts that have been accessing our environment from those locations. So I have now my IP addresses and my account object ID. I don't have the username because, remember, Cloud App Events do not provide this information. So what I'm going to do now is to reuse the information that I got here and filter the activities based on the IP addresses that we extracted with the first part of the comment. And I'm going to do a second join with the identity event by using the user ID property from identity info and account object ID from my cloud application events. And by doing this, I'm going to have now additional information like the account display name, account UPN, department, country, etc. So let's run this command now to see if we have other impacted user. And by running this query now against all the cloud application events that we have, you can see that now we have the other user that might have been impacted. So we have our Megan Bowens account. We have also another user like Seb. So that might be my account. And something very convenient, when you click on a compromised account, you already have the investigation priority. So if we look at just this information, we can already see that this user seems to be at risk. So probably you will have to go through the same investigation that we went through this time and analyze the behavior of that specific user, because that user might be also impacted by the attack that we had before. So now that this is something that we've seen and that you would reuse, I want to also add just a quick bonus, because in some cases, after identifying a compromised user, you might want to see what that user actually did by sending some additional emails, maybe sending some phishing emails, some malicious attachment. And we're going to do this again using our Cloud App events. So this time what I'm going to do, as a bonus, of course, I'm going to this time search for actions that will be sending emails for our account object ID. So in this case, Megan Bowens. And you can, of course, apply additional filter, maybe by searching for a specific location, searching for a specific IP address or specific user agent. And I'm going to add additional information like the user key, the message ID, and details like the subject of the message and if that message had attachment. And before joining this to the email event, let me show you how it looks like. And here we can see that our user only sent one message. And if I look at the data, we have details about the location here. We have also details about the user agent. So we can see that it was sent from a regular Outlook client, and we have additional information from the emails. So I'm not going to reuse all that information. What I'm going to use now is also an additional data set, which is the email event that we saw before. And if you're wondering why I'm using Cloud App Event in addition to the email events, because email event contains all that information. I can easily see the emails that have been sent by the user. The reason is that Cloud App Event is going to add additional information like the subject of the message or the user agent information. So that's something that might be very interesting when you're investigating the emails that have been sent. So this time, again, I'm joining using the message ID, and I'm projecting specific information that will be useful for me. And after doing this now, I can easily see that this user sent one email using the regular Outlook client. The subject was welcome back, so probably not something fishy that was sent to another user. And if I continue and look at data that came from the email events table, I have now details like the recipient. So I can see that my Megan user sent to my Seb user an email that was named welcome back. It has been delivered normally, and we can see that it was that there is apparently no thread that has been detected, and there are no attachment and no URL. So we can assume that we are safe and that no malicious information has been set or sensitive data has been extracted using that mailbox of our compromised user. And this concludes my demo. I will give back the mic to my dear colleague, and maybe here if we have some question in the chat that you want to cover.
Thank you, Seb. So I would like to ask Michael a question that we are getting a lot. And if you can please explain what is the difference between Sentinel and Microsoft 365 Defender in terms of hunting, when I need to hunt in which place?
Absolutely. So there are some similarities between Sentinel and Defender. Most notably because they both use the same language. It's all Kusto query language behind both these technologies, and they both do log security data. But there is a notable difference between advanced hunting and Sentinel from a product perspective. So Sentinel is going to allow you to forward a number of different types of logs arbitrarily, and you basically have the ability to pay for the storage and retention for those logs. Microsoft 365 Defender provides advanced hunting as an inbox capability. So this is actually, so the 30 days worth of retention is actually included in your current licensing. Another important note is that, so with advanced hunting, we have the ability to trigger response actions based on custom detections. So you can use your Kusto queries to automatically trigger endpoints to isolate. You can trigger quick scans, collect forensic packages, a number of different things like that. So there's definitely, in the sense that they both do collect security data and they both do use KQL, there are some similarities there, but there's a couple notable differences really in the way that the tools operate and interact. Another important note is that with Defender, you're basically working off the data that we collect from our variety of sensors. So the Defender for Endpoint Sensor, Defender for Identity, MCAS, and Defender for Office. So those are basically native integrations. We don't have extensibility to pull in, for example, arbitrary logs. That's where Sentinel really comes in.
Thanks, Michael. I would like to add, just for clarification, that the most easy way to think about it, if you want to hunt only on Microsoft data, use Defender Advanced Hunting, because all of the reasons that Michael mentioned. If you would like to combine this data with more data sets, with third party, this is where you will pivot to Sentinel.
Great. Do you have any additional questions, Tali, that you would bring up? Because I saw there's like so many awesome questions that have been asked as well as answered. Anyone?
Maybe one more. We got a question how you can connect Microsoft Cloud App Security into Defender. So it's actually super easy. You just need to go to security.microsoft.com and enable Microsoft 365 Defender. Once you enabled it, the data flows. The alerts, the raw data, everything will just pop in the product.
Thank you. And I think this is a good call out to send people as well to our tech community, where we also have a blog space, where I think there is a couple of blogs on the integration of Microsoft 365 Defender and Sentinel and such. So with that, thank you so much again, Michael, Sebastian, and Tali. A few reminders before we are going to end this call. Of course, the recording will be made available. There is no slides, but the recording can be found on aka.ms/security-webinars. We have an awesome schedule coming up. I'm just copying, just mentioning the next 4 which is tomorrow, Azure Network Security, Central DNS Management, and Logging with Azure Firewall. The day after, Microsoft Cloud App Security, Protect Your Box deployment using MCAS. May 13, Azure Security Center, Azure Workbooks in Security Center, as well as then we have on May 18, which is next Monday, Microsoft Defender for Endpoints, Stopping, Cabernet, and FIN7, Understanding the MITRE results. And again, for details and registration, please go to aka.ms/security-webinars. If we missed to answer your question, or if you have additional questions, you can always come to the Microsoft 365 Defender forum at aka.ms/m365dtc. And again, Michael, Sebastian, and Tali, thanks for today's episode of Lead Speak. I'm looking forward to the next one. Thank you to the rest of the team who helped answering the questions. And most of all, I want to thank all of you for being part of our community and for joining us on those webinars. Please provide feedback so we can always come with the sessions you are looking for. Hope to see you next time. Goodbye.